So in the last video, we learned how to use our periodic table to figure out what a specific element's ion charge would be if it was involved in ionic bonding. Now we want to use those charges to figure out what the formula of that ionic compound would be. So the key here is that we're trying to form what's called neutral ionic compounds. And neutral means no net charge. Or in other words, positives and negatives combine to equal 0. So, how does that work? Well, with the one we saw before, it's really straightforward. You had a lithium ion that was positively charged, and you had a chloride ion that was negatively charged, so that equals 0. 1 positive, 1 negative equals 0. So we just wrote the formula for that as lithium chloride. But what about if it was something a little more complicated? What about if it was something like lithium, which has a positive charge, combined with oxygen that has a -2 charge? So we would be combining lithium and oxygen with a 2 negative charge. Well, as of right now, that does not add up to 0. Positive and 2 negative equals -1. So that's not a neutral compound, just combining the two of those together. But if we had 2 lithium atoms, that would be 2 positive charges to go with a 2 negative. That now equals 0. So that's what we're going to do. We're going to combine 2 lithiums with 1 oxygen to make a neutral compound. And the way we write that in a formula is Li with a subscript 2O. 2 lithiums combined with 1 oxygen make a neutral compound. That can work a lot of different ways. Let's look at a complicated one. Aluminum, which is right here, has a 3 positive charge combined with sulfide, which is the negative ion of sulfur over here, which would have a -2 charge. So if those two wanted to combine to make a neutral ionic compound, it gets a little complicated. A 3 positive and a 2 negative are not equal. Those do not make a neutral net 0 charge compound. So let's just sort of work back and forth and see what we need to combine here. I'm going to break this up. I realize they're probably bleeding together a bit, so just, there you go. So if we were combining the aluminum and the sulfur, then we would need another sulfur. But that's now 2 and 2 is 4. 4 negative and 3 positive isn't equal either. So let's add another aluminum. We're still not there yet. 3 positive plus 3 positive is 6 positive, where 2 and 2 is 4. You can probably see where we're going now if we add another one of those. 2 and 2 and 2 is 6 negative. 3 and 3 is 6 positive. So that finally makes a neutral compound that adds up to 0. So our formula would have 2 aluminums and 3 sulfurs. Like that. 2 aluminums and 3 sulfurs would make a neutral ionic compound. Let's try one more. So this one's going to be a little weird. We're going to use a transition metal that can have a charge of 4 positive. So titanium with a 4 positive charge combining with oxygen with a 2 negative charge. So again, 4 positive, 2 negative don't add up to 0. So we're going to need to add another oxygen, 2 negative. 2 plus 2 is 4. 4 negatives, 4 positives adds up to 0. So we're going to have TiO2 for our formula. Works out like that all the time. There's one neat little trick that you'll see in your textbook, but I want to sort of point out the beauty of it and the flaw right away. Is that you'll notice when you have these odd even things, you're looking for a least common multiple. So the combined amount of charge is the multiple of the two. 3 times 2 is 6. So that's how many positives and that's how many negatives we need. The way that works out is 3, the charge of one of them, is often the number of the other that we need. So 3 aluminums results in, sorry, my pen is slightly running out. You need to use 3 sulfurs. A 3 charge on aluminum is the number of sulfurs we need, and the -2 charge on the sulfur often ends up being the number of aluminums we need. Now, that works especially well for these kind of odd-even situations where it looks complicated. But it doesn't always work so well for this. If you had done it here, you would have thought we needed 4 oxygens and 2 titaniums, but that wasn't correct in this case. If you had written Ti2, because that's the charge on the oxygen, O4, because that's the charge on the titanium, you would have actually had double the correct formula, and you would have needed to reduce that to get the correct formula. So you can choose whether or not you want to use that shortcut. I just wanted to point out what it works great for and what it doesn't work as well for right here. So do this next activity and come back for the next part.